Next we see that is regular Falsy method. The objective of each method is same. Now we have to see what is the difference between the workings. What is the difference between the result? Which method is the better? No method is bad. No, each method is better. But second is better than that first one better. Now let us discuss regular Falsy method. Regular Falsy method, or we call it false positioning method or code method. That is the same thing. False positioning method or the code method, it is the regular Falsy method. Again, the objective is same. We have to find out the exact value of the variable no by using this method, not by the bisection method. No. First of all, we see the formula used in this method, that is, say x2 is equal to x0 into f of x1 minus x1 into f of x0 divided by f of x1 minus f of x0, who are 0, 1, 2, then we will identify them during the solution. That may be the different from the some method formulas written in the book, but it is the same. It is solved method. Solve the, again we consider the function. Solve the function f of x is equal to 2x cube plus 5x square plus 5x plus 3. Find the exact value of the x, or find the exact root of this function by using regular Falsy method. Here we have considered the total algebraic function. Again, the problem is that from where should we start? What is the starting initial point or the starting point? For that, again we follow the hit and trial method. Say we start with, that is f of 0, that is equal to 0 plus 0 plus 0 plus 3, that is equal to 3 greater than 0, and f of 1, 2 plus 5 plus 5 plus 3, that is equal to 15 greater than 0. It means if we will continue the putting the values, positive values, it will continue increasing and there is no chance we get the negative value. So what we do? No, we proceed on the other side of the 0, that are the negative values. Say f of minus 1, that is equal to minus 2 plus 5 minus 5 plus 3, that is equal to 1 greater than 0. Then f of minus 2, that is equal to 2 into minus 2 cube plus 5 into minus 2 square plus 5 into minus 2 plus 3, that is equal to, if we calculate it, that is minus 3, and it is less than 0. So we get the first oscillation. How? As we are moving from, we are changing the value of the variable from minus 1 to minus 2, the value of the function changes from positive to negative. That's the initial point where we stop. We consider that the required root or the required value lies somewhere near minus 1 and minus 2. So the next value lies between minus 1 and minus 2. Again we draw the number line. smaller value we consider x0. Smaller value is -2 and greater value, that is -1. We write here -2 -1, it is x0, it is x1. Now we have to find the first root or the first value. It is somewhere here, it is not the middle point, it is not the bisecting point, it is somewhere between -2 and -1. Say it is x2. Now we follow this result, that is x2 is equal to x0 into f of x1 minus x1 into f of x0 divided by f of x1 minus f of x0. Each and every value is available. See, what is x0? x0 is -2 into f of x1. f of x1 means f of -1 minus x1 -1 into f of x0 -2 divided by f of x1 f of -1 minus f of -2. Now substituting all the values, -2 into f of -1 we have calculated here, that is equal to 1 minus what is x1? x1 is -1, f of -2 that is -3 divided by f of -1 1 minus f of -2 -3. That's come to be equal to -2 -3 divided by 4, that is equal to -5 by 4, that is equal to -1.25. Here we get the result up to decimal 2 place. So what we have seen, what is the difference between the bisection method and this method? In the bisection method, nowhere we used these values. We were only concerned with the sign greater than or less than. But here we are using these values in the given formula. That is why this method is much more accurate and faster than the bisection method. Now again we can repeat the other step in the same manner. Say here is the value -1.25. Again the same situation arises, that the next value lies either on this side or on this side, either on left or on the right. For that again we consider the given function, that f of x, and put this value f of -1.25, that is equal to 2 into -1.25 cube plus 5 into -1.25 whole square plus 5 into -1.25 plus 3, and we calculate it, that is equal to, if we calculate it, that will come 0.656, and it is greater than 0. And that comes to be 0.656, it is greater than 0. Again we follow the same method which we followed in the bisection method. If its value is greater than 0, then our next value lies on the left hand side here. If it is greater than 0, then this value lies on the left hand side, and we will draw the new number line like this. Say it is -2 and -1.25. Again we consider it is x0 and it is x1. We start again with the same position x0 and x1, and we delete this number line and we assume that is the new number line. Then x3, again we write the same formula, x3 that is equal to x0 into f of x1 minus x1 into f of x0 divided by f of x1 minus f of x0. So what we are doing? We are keeping the formula same. We are keeping the formula same, but we are changing the number line. If we keep the number line same, then we will have to change the formula every time. That may be the difference between the different books. But here what we are following, we are keeping the formula same and we are changing the number line. Now we forget about this. Again, it is a new x0 and new x1. We put these values. What is x0? Here now it is minus 2 into f of x1 means minus 1.25 minus x1 minus 1.25 into f of minus 2 divided by f of minus 1.25 minus f of minus 2, that is equal to minus 2 into f of minus 1.5, that is 0.656 minus plus 1.25 into f of minus 2. F of minus 2 that we have it in the previous problem, that is equal to minus 3. In the previous step it was minus 3. Then f of minus 1.25, that is 0.656 minus f of minus 2, that is again equal to minus 3. Now this value if we calculate, that's equal to 0.656 into 2, that's equal to minus 1.312 minus 3.75 divided by 3.656, that is equal to 1.312 5.062 divided by 3.656 minus, that is equal to 1.38457. So